Assalamualaikum warahmatullahi wabarakatuh. This is the second video for the deflection of simply supported trust bridge, which is method of analysis. There are two types of method of analysis for trusses. The first one is method of join, while the second one is method of section. The method of join is a process used to solve for the unknown forces acting on the members of a trust. This method centers on the joins or connection points between the members, and it is usually the fastest and easiest way to solve for all the unknown forces in a trust structure. The second method is method of section. The method of section is a process used to solve for the unknown forces acting on the members of a trust. This method involves in breaking the trust down into individual sections and analyzing each section as a separate rigid body. A method of section is usually the easiest way to determine the unknown forces acting in a specific member of the trust. This is the image, or when we are conducting our experiment, we are using wooden stick as a truss and batteries acting as a load. The type of method of analysis that we use during our experiment is method of joins. Now I will talk about the steps to use method of join. The first step, calculate the reaction at the support. First, you need to solve the equilibrium equation for the unknown. This step can be done algebraically by solving for one variable at a time, or using metric equation to solve for everything at once. If you assume that all forces were tensile earlier, remember that a negative answer indicates compressive forces in the member. Second step is consider one of the support and find the internal forces. To calculate forces on the truss, you will need to use trigonometry of a right triangle. A right triangle is a triangle in which one angle is equal to 90 degrees. If the angle is 90 degrees, the two sides of the triangle enclosing the angle will form an L shape. To calculate the forces on the joint, you will sum the horizontal forces and set them equal to 0. Separately, you will sum the vertical forces and set them also equal to 0. The last step in method of joint is calculating the vertical and horizontal displacement. This displacement analysis can be conducted by using uniload method, and like the method of joint, equilibrium equation will be used. The displacement of the joint can be determined by using displacement equals to small n times capital N times width L divided by A times by E, where small n is the virtual load due to a unit load applied at the joint of the interest. Capital N is the internal force in the member due to actual applied load. A is the cross-sectional area of the truss member, and E is the Young modulus of the truss member. That is all from our team. Thank you and have a nice day.